All right. Good evening, everybody. Welcome to Casey Lee Live Software Edition. For those of you who are new to this is basically a live stream that's been generally happening every Thursday night at 8 p.m. Eastern Time. And it's basically a place where we talk about software, software development, whether it be web development, mobile development, desktop app development, whatever it may be, software concepts, software theories, all these kind of things. And we do it live. So there's definitely some customer interaction, or customer, I guess, viewer interaction is the word I'm looking for. It's been a long week, apparently. I'm pretty tired. So what this is, again, for those of you who are new to this, it's basically split up into two main pieces. The first piece being a formal kind of lesson or talk or lecture or whatever you want to call it. So every week I prepare a little something that talks about some kind of software concept. So in the past, we've done things like an introduction to SQL. We've done things like the importance of semantics. We've done some live coding sessions, these kind of things in the past. And so the first part is all about a formal lesson. And then after that, I kind of take questions, from you guys, the viewers, about anything really. It could be about the topic that we covered. It could be about something that we haven't covered, suggestions for future streams, these kind of things. So definitely in the planning phases of some new things we're going to add to this, whether that be bringing on some guests. I've been talking to my friend Dave, who might be here, either next week or the week after. We're going to plan some kind of coding session, some technical logistics to figure out, and also just a topic for us to figure out before we get going. But definitely want to do that. So good evening to Dave. There he is. He's already talking there. We already have at least one more viewer than we've had in the past, so that's always good. So say hello if you want. Again, if you guys are new to this, do keep your privacy in mind. This stuff is public, and it stays public after a while. You can redact your comments, but obviously this part's recording. Definitely feel free to ask questions throughout. As you can see, there's a chat there. And even after this chat disappears, I'm going to keep my eye as much as possible on the chat window on my side if you guys have any questions. Again, if you're new to this, you can always follow me on Twitter right over here, KCLee23, or you can leave comments on the YouTube video itself. Oh, Mark has joined us, so hey to Mark as well. These things at Thursdays at 8 p.m. is not good for you. Right after, pretty much within minutes, if not maybe an hour, like I don't know how long it takes, but this thing goes on recorded on YouTube, so if you miss any, you can always come back and view these sessions afterwards. I know we have some people who view these afterwards, so definitely want to welcome those people as well. And again, if you're new to this, don't forget to subscribe to my channel and hit the bell icon to get notified. What that does, one, is it helps my channel, helps spread the word about my channel, but for you guys, it lets you get notified in case you forget, hey, Casey's going live. He's going to be talking about some software topic. The software topics that we talk about, we generally tend to go more on the technical side. So we are kind of anticipating that the people who join these talks understand some things about coding and some programming, stuff like that. But there's definitely some non-coding topics that I plan to cover in the future as well. Things like product management, process management, these kind of things. All very important to being a software engineer. It's not just about coding, right? Lots of stuff about process management is very important as well. I don't think there's anything else, but and just on that note, again, I really want this to be driven by the audience. So if you guys have any topics or suggestions or would like to hear anything about that, definitely feel free to suggest that. So all right, so why don't we just get started? We're going to jump right into it today. Okay, so welcome everybody to the April 30th edition. I just realized last week when I did it, the dates were all wrong on everything. Actually, I said April 24th on everything. Not a big deal. People still joined, I guess. But it said April 24th and it was April 23rd. So kind of realized that when I was making the slides this week, and I was like, that's not 7 days more. Anyways, okay. So a couple of weeks ago, we did a little chat about SQL. The SQL query language. Now SQL, for those of us who for those who weren't able to make it last time, it's a very important topic in the sense that it is still a very prominent way. Prominent may is the wrong word, but very much a very popular way to store data. There are definitely other ways to store data. Obviously, storing data in plain files, your own proprietary language, storing files in terms of like CSVs or XMLs, these kind of things, and even going now more recently to storing your data as key value pairs, kind of like in a JSON fashion. Is getting very popular as well, but still a massive amount of the way a lot of software works is storing things in SQL databases. That's still very, very much a very popular way to do it, and not to mention it has a lot of advantages. Just because these new things are popping up doesn't mean SQL is worse. It doesn't in any way mean it's worse. It just means it's a different way to do things, and SQL has a lot of advantages actually. Now I grew up in a SQL world. I learned a lot of SQL in university, and I did it throughout a lot of my career, and I still use it very much today in my career. So it's still very, very important topic. And in fact, a lot of the newer technologies that are coming out still reference SQL as a reference point because so many people know SQL or so many people come from a SQL background. So again, I've said this before, but like tutorials like on Firebase, they have all these whole branches of videos dedicated to if you're coming from a SQL background. So I don't want anybody for a second to think that SQL is like the old news or the old way to go. It may be in some day in the future, but right now it's still very much a relevant thing to learn. And I do want to stress that it's not just because it's popular, but it does have its own advantages in doing things the way that we do things. And one of the things actually that it brings up are some theoretical concepts that work well in a lot of different contexts. So it's kind of good to learn those. And we're going to learn some of that stuff today. Some stuff that's a little bit theoretical, but then we're obviously going to see the actual real implementation of it using the vendor that I use, which is PostgreSQL. So there are a lot of different vendors of SQL databases. There's Microsoft, there's PostgreSQL, there's MySQL, there's SQLite. A lot of different people make SQL databases, but I'll show you what it looks like in PostgreSQL. So what we did last time was we did a brief intro to SQL databases, and we showed you what SQL databases are and how to deal with the data inside those databases. We talked about how to insert data, how to select data, how to delete data, these kind of things, and we'll be seeing a little bit of that here today. So this talk will definitely help if you have a little bit of knowledge of SQL databases going into this, but you'll probably be able to follow even if you don't. But that was scratching the surface, and we kind of dipped a little bit into things like where clauses. I don't think we talked about order or limit, ways to kind of modify your queries, which are very important. And that's not exactly what we're talking about today, but that's another way to kind of increase your SQL knowledge, is understanding how where clauses work, how limits work, how order bys work, these kind of things. But today we're going to cover another very important topic that has to do with SQL databases, and in fact is what makes SQL databases what we call a relational database. So relational databases is all about tables that are related to each other in some way, right? Last time we talked about kind of these disparate tables, like you had a products table and a users table, but they weren't related in any way, right? Those two tables kind of existed independently. And so today we're going to talk about how do you relate that data together, and how to structure it in a way that makes it easy to deal with, basically, right? So that's what we're talking about today. And to do that, we're really talking about two important concepts. One is the idea of primary keys and foreign keys. So that's the first concept we're going to talk about. What exactly is a primary key and what is a foreign key and how do they work? But primary keys and foreign keys are not necessarily that useful on their own. They are in some sense. But they become very powerful when you start to incorporate them in what are called join queries. So we'll talk about join queries at the end of this and how that works and how that can kind of improve the performance of your application and can kind of really get you to where you need to be. Okay, so let's talk about primary keys and foreign keys. So again, I'm going to be talking about this in the context of SQL databases, but this generally should work for any relational database. I actually am not familiar with relational databases other than SQL. databases. There might be some others. I'm sure there are. But basically, we're talking about databases where, again, certain sets of data are related to other sets of data. So here we go. So we're talking about primary keys and foreign keys. So first of all, why do we have these? Why do we have primary keys and foreign keys in databases? So the one of the best uses for primary keys and foreign keys is that it's a great way to model or structure your data so that it's normalized. Okay, so we usually have this goal in relational databases to normalize our data, and we're going to talk about what normalization of your data means, but that's usually one of the goals when we talk about structuring our data. When you get into database modeling, in other words, I mean, database modeling is just kind of a fancy way to talk about what your data is going to be, how it's going to be structured in the database. So in other words, what are your tables going to be? What are your columns going to be? What's the data that's going to be stored in those columns? These kind of things, right? So sometimes people call it database design, right? Like database modeling or database design. Like when you sit down to program an application, or you sit down with your friends or your coworkers or whatever, and you start to figure out how we're going to store our data, you need to start talking about what the table names are, what tables you're going to have, what columns you're going to have, all these things. This is all about structuring your data, or database design, or database modeling. Okay, so those are kind of words that people toss around when we're talking about that. So when it comes to database modeling in relational databases, one of the goals we usually have is to normalize our data. So what does normalizing our data mean? Again, we'll talk about it in a second, but a way to execute normalized data is by using primary keys and foreign keys. So normalized data, it's one of these chicken and egg problems when I was trying to structure this talk here, but this will become very clear when we actually look at primary keys and foreign keys. But I'm going to talk about briefly what normalized data is right now. So normalized data is the idea that you don't duplicate your data. Okay, you basically are trying to I looked this up on Wikipedia, but the idea is reducing redundancy. Okay, so don't duplicate your data. That means if you have a piece of data that pertains to something in real life, that's a good way to look at it. It's something in real life. Okay, that you don't repeat that data in a bunch of different places. Okay, so don't duplicate your data, right? So for example, you may store a first name and a last name of a user. Okay, so my first name Casey, my last name Lee. The idea is that we only really want to store that in one place. We don't want to store that in a whole bunch of different places. And you might think, what do you mean by storing it in a bunch of different places? Well, your name, my name, that username may appear in a lot of different places in your application, but where we store it should only be in one place. And this will become, again, more evident the more we go through this example, okay? So I just want to give you a taste of what normalized data means, which is not duplicating your data, and that primary keys and foreign keys are a way to not duplicate your data, okay? So let's talk about that. Okay, so what are primary keys? Okay, so primary keys, if you think in SQL database terms, so SQL database is a bunch of tables, okay? So in one given table, okay, a primary key is basically a column or a combination of columns that uniquely identifies a row in a database table, okay? So what do I mean by that? So let's take a look at a users table, for example. Okay, so here we have a users table. This is actually very similar to the one we were looking at before. So here we have an ID column. Okay, so we're numbering our users, 1, 2, 3. Have a first name and a last name, Casey and last name Lee. And then we have age, and then we have a student number. Okay, so when you think about a primary key is any column or any combination of columns, okay, that gives us a unique identifier. Okay, some way to uniquely identify a given row or record. Okay, so in this case, we could have taken a couple of things, and I'll generally say when you're getting started out, and even when you're pretty advanced, if you can make a primary key out of one column, it'll make your life a lot simpler. There are certain instances where you'll want to make a primary key out of multiple columns, but it's a lot easier if you just make it out of one column. So in this case, we'll just talk about primary keys in terms of one column. So in this case, what we have is we have a couple of candidates here. So ID would be a great primary key, right? Provided that we control how that ID gets populated. Okay, so it's very common in web applications, mobile applications, like in desktop applications, that ID column is just an incrementing number. So anytime you insert a new record, you just increase that number. Okay, you keep increasing that number. And even if you delete rows, you just keep incrementing that number. And that way you would guarantee that every row has a unique number. And then therefore you guarantee that ID is a primary key. It's a unique identifier. Now, the way that student numbers are usually designed in things like universities, colleges, high schools, whatever, education institutions, student number usually is unique as well. So provided that we know that every single row is going to have a unique number, student number would also be a good primary key. And so you could use either, really. Okay, you could use either as your unique identifier to identify that row. But the important thing is that if I were to say, find me the row where this column is equal to this value, it will only return one row. That's the real benefit of a primary key. Okay, uniquely identifies it, right? So some examples of a bad primary key in this case, first name would be a bad primary key, right? First name, obviously there could be multiple people with the name Casey. Last name's bad as well. There could be multiple people with the name Smith. Age is also pretty bad because a lot of people are the same age, right? So these are bad primary keys because they don't uniquely identify a row. Okay. So sometimes when you're designing databases, sometimes the easiest thing to do is just say, we're going to create this value called ID that actually has nothing to do with the real world. It's just the way we uniquely identify it in our application. Because the problem is when you start to tie things to the real world data, you very, very, not frequently, but sometimes you run into situations where you don't realize there's a duplicate, right? You might be like, oh, we're going to do it, somebody who's born, like we're going to do it by their birth date, birth time, down to the millisecond. That's what we're going to do. And, you think that would uniquely identify everybody. But then you realize, no, there's two people around the world who were born at the exact same time. Right? So these kind of things. So sometimes it's easy to just say, we're going to assign ID as our primary key. Okay. Not always, but it's a pretty easy practice to deal with that way. Okay. So that's what a primary key is. Primary key is a column that uniquely identifies a row. So in this case, I'm saying ID could be the primary key or student number could be the primary key. Okay. So now that you know what a primary key is, what is a foreign key? Okay. So a foreign key is a column, again, or set of columns. In our examples, we're going to use a single column that references the primary key in another table. Okay, so you're in one given table and you have a column that is referencing really the primary key of another table. Okay, so what does that look like? Okay, so this is our users table. Okay, and we had a primary key called ID, and then we had a bunch of values around there. Okay, so now for the first time, we're going to look at how two tables can be related to each other. Okay, so let's say we introduce a new table called orders. Okay, so picture like this would be like orders, like if you ordered something online. Okay, so let's say our database, our application has a bunch of students in it, and they can purchase stuff from us. And so we have the ability to purchase stuff, and when they purchase something, there is an order that's created. Okay, like an Amazon order or something like that, right? And we're gonna make this order really simple. We're just gonna store a couple of things. We're gonna store the date that the order was made, the subtotal. So in other words, how much was the order worth before taxes? So $200, $100, $10, and then the total with taxes. Okay, so we're just gonna store these three values. Okay. Now, if we want to uniquely identify these orders, we can have a primary key in that table as well. Okay, so I'm going to create an ID column in the orders table, and that's a primary key. So the primary key for the orders table is ID. The primary key for the users table is ID. Okay, remember when we talk about primary keys, it's always like in reference to the table. Okay, but now we're going to talk about in reference to the two tables and how they interact with each other. Okay. So let's say that I know I'm going to store the orders and I'm going to store the users, but it would be nice to know which orders belong to which users. Okay. So let's say the first order made on April 1st and the second order made on April 18th. Let's say those are both actually made by Casey Lee up here. Okay, Casey Lee, age 38, student number 222333444. Let's say that's the person who made these 2 orders. And let's say the third row on January 3rd, that order was actually made by Casey Smith. Okay, and then John Smith didn't make any orders. Okay, so how do we actually relate the two? Okay, well, what we can do is we can add a column to the orders table. Okay, and we'll call it user ID. Okay, and so in this case, what we're saying is, okay, this row with ID 1, that actually belongs to the user whose ID is 1. Okay, and the same thing with row 2. So row 2 belongs to the user whose ID is 1, and row 3 belongs to the user whose ID is number 3. Okay, so in this case, the user ID column is a reference to the users table above it. And in fact, it's referencing the primary key of the users table. Okay, so this user ID column is not the primary key in the orders table, because that primary key of the orders table is this ID over here. And in fact, it definitely could not be a primary key in the orders table because there's duplicates here, right? There's 1 and 1. But this is referring to a primary key of the users table. Okay, and that's what we call a foreign key. So a foreign key is a column in a table that references a primary key in another table. Okay, and that's what's there. Okay, now hopefully that makes sense. Okay, and here's a diagram to kind of make it a little bit more concrete. Okay, so that's how they link up. The user ID references the primary key up here, and the user ID references here. Okay, now one thing I want to be clear about here is primary keys and foreign keys by themselves do not add any benefit. So just by putting in a key, a foreign key or a primary key into a database table, it doesn't really do anything at that point. Okay, it's not until you start to query the data and use the knowledge that they're linked that we can then maximize the power of what this does. Okay, so don't think just by putting a foreign key in and a primary key in that things are going to automatically work for you. Okay, there's stuff then you have to do to your queries to make this all work out. Okay, but this is the setup. This is what you need to store in order to have this setup. Okay, so like if you weren't storing the user ID, there'd be no way to tell what orders belong to what users. So this is part of the setup. Okay, so when you're thinking about your database modeling and structuring your data, you want to think about the foreign keys and the primary keys and how everything's going to link up. Okay, so on that note, by the way, in terms of how we name our columns, okay, it actually doesn't really matter in the sense that functionality wise, you can name it whatever you want. I could have called this user's ID or person ID or something like that. I could have called it whatever I want. Okay, but it's generally good convention to have something that references the table and the primary key itself. And that's what's really nice about this, right? Because if we called this table users above, it'd be really easy to know, oh, this references the users table. Okay, and in fact, this is a convention that, again, Ruby on Rails uses. Okay, so a lot of my knowledge and best practices come from Ruby on Rails. Okay, but that is simply a convention. In other words, it doesn't actually increase the functionality in itself. Okay, all it does is set you up nicely for what you're about to do with your queries and stuff like that. Okay, last week or 2 weeks, I can't remember when we talked about it, but when we built the ORM, there are advantages there. If you're using a third-party ORM, how you name your columns, but they won't work automatically out of the box if you're building your own. Okay. All right, but that's a little bit of an aside. I just want to recap what a primary key and a foreign key is. Primary key uniquely identifies a row in a table. A foreign key references another table's primary key so that you can link up the data. And this is why we call these relational databases. We're relating the data to each other. Okay. So now the idea of normalized data is going to make more sense. Okay, we talked about normalized data being don't duplicate your data. Okay, so if we look at this diagram here, okay, we are not duplicating the person data, right? The first name and the last name of Casey Lee. So we have an orders table. Let's say we had a bunch of other tables. We had like a shopping cart table, and let's say we had a favorites table, and we had a we had a classes table, and all these other tables. Okay, and they all reference Casey Lee. Well, if we just reference it by this foreign key, then what's really nice about that is we then would not, sorry, if we reference it by this foreign key, then what's nice is that the name Casey Lee, age 38, student number 222333444 is only stored in one place. Okay, and then what's really nice about that is if we go to edit Casey's name or age, let's say Casey turns 39. Okay, we only need to edit that in one place. And this is one of the really nice things about normalized data. When you go to edit or update anything, you only have to edit it or update it in one place. Okay? So that's what normalized data looks like. Now, you might be thinking, this is really obvious. This makes, like, of course, why wouldn't we normalize data? Like, what does non-normalized data look like? Or some people call it denormalized. I like to say non-normalized because denormalized seems to imply that it was normalized at some point. Okay, but anyways, so what does non-normalized data look like, or denormalized data? Well, denormalized data would look maybe something like this. Okay, so in this case, if I were to store the user's name, first name, and last name on the order, I'd have to repeat it for every order that person makes, right? So the name Casey and Lee are stored, up here and down here as well. Okay. Now there are advantages to this, which we're not going to talk about. Today, unless there's time for questions or whatever afterwards. Well, there will be, but we're not going to talk about that in the formal lecture today. But this is what denormalized data looks like. And again, there are advantages to this, but when you're generally modeling and creating a SQL database, especially if you're getting started out, you want to avoid this kind of data. You want to normalize your data as much as possible. And if you have a foreign key, that really allows it. And in fact, if you look at this, if our only goal is to use the first name and the last name on a given order, we might not even need the foreign key column. We could get rid of it entirely. Okay. All right. So that's what denormalized data looks like. Okay, so now hopefully you guys understand what a primary key is and what a foreign key is. Again, as we go along, feel free to ask questions. You can just type them in the chat. I'm still monitoring the chat while I'm giving the lesson here. But hopefully you guys understand what a primary key is, what a foreign key is. Okay. Join queries. Okay. Just a couple minutes ago, I said that primary keys and foreign keys by themselves are not particularly useful. Where they become useful is when you start to use them in your join queries. Okay, so what are join queries? All right, so if you take a look at our last example here, okay, we have users and orders in there, okay? Now, when you start to build an application, you are going to start to extract data from the database and put it into your user interface, right? And, we talked about this last week in terms of building your own ORM, right? So the question is, when you go to build your UI, how are you going to do that, right? And if you were only going to grab data from one table, let's say you want to show the order, okay? Well, if you're only going to grab data from the orders table, you could show the subtotal, the total, and you could show the user ID. Well, okay, the user ID is not very useful because that's just kind of an ID that you artificially created in the back of the database. So if you had some administrator who wanted to see whose order it was, they'd be like, oh, that's that order belongs to user ID 1. Who's user ID 1? How do I get in contact with that person? Okay, well then maybe you want to click on, maybe you click the one and then it goes to another screen or another page and that'll show the information. But what if you wanted to actually show all that information together on one user interface? Well, then you might need to grab data from multiple tables. Maybe we want to show the first name, the last name, maybe the person's email address and phone number and all that stuff, right? So let's give an example here. So let's say this was the user interface, a really simple user interface to show the order. So we show the order ID at the top, so order number 3, and then we show the customer information. So the first name, the last name, the email address, and the phone number. So let's say the email address and phone number are stored in the table. I know I didn't have that in my diagram, but let's say the email address and the phone number are stored in the users table as well. Okay. And then we have the subtotal and the total. Okay. So the order number and the subtotal and the total, and actually the date that this order was created, we could grab all that from the orders table. But to get the first name, last name, email address, and all this stuff, that we'd have to grab from the users table. Okay. Well, that's not a big deal, right? You guys would know how to do this. So first thing you would do is you'd use your ORM and do some kind of query on the orders table. So you select star from orders where ID is equal to 3. So that would get us the subtotal, the total, and the order ID. Okay. And then you use your ORM to do a subsequent query. You do a second query. So because you grab the order in the first query, you know the user ID of that order, right? So you know the user ID of that order. So once you have that number 1, then you can do a second query. So select star from users where the ID is equal to 1. Okay. Now, this is fine. This is fine for one order. It's only 2 queries, not that big a deal. Okay. But as your app grows, this can have a serious impact on your performance, and can have a serious impact on when you're kind of going through your data, especially when you talk about things like lists. Okay. If you say wanted to show a list of all the orders in your system, you would have to do this for every single order, right? So what would normally be kind of, a really quick query, if you just select star from orders, you just select star from all orders, that'd be quick. But then if through each order, then you have to do a subsequent query, that might take a lot longer. And then you have to think about, well, what if it's more than just 2 tables? What if it's like 3, 4, 5 tables to get all the information you need to display on the user interface? Well, again, this starts to have a serious impact on your performance. Okay. So this is where join queries come in. So join queries basically give us a way to query multiple tables in one single query. Okay, so we can get the data from 2 or 3 or 4, how many ever tables you want to do, just from one single query. And that really optimizes performance. Okay, so the thing about SQL databases that you need to understand is that the reason they're so powerful is their query engine is very performant. Okay, so when you do a select star from orders, and even if it's 1,000 orders, you can get 1,000 orders back really quick, right? But if you have to go to the database, grab those into memory using your ORM, and then iterate over that and perform one query for each one of those orders, every time you're connecting to the database can be a bottleneck. Okay, once you send one query to the database and get them to do the query, it can be very, very performant. So the less times we have to go to the database and the less times we have to run queries, the better. Okay, and that's what join queries help us do. They allow us to grab data from multiple tables in one single query and return those results as a single row with columns from both tables. Okay. All right. So this is what a join looks like. Okay. So the way it works is you do select star, which means you're going to select all the columns from table 1 joined with table 2. Okay. And then you have to specify what you're joining them on. Okay. Which means what are you using as your matching criteria between table 1 and table 2? Well, that's why we talked about primary keys and foreign keys. Because usually what you would do here is you would say, select star from table 1, join table 2, on table 1.foreign key equals table 2.foreign key. Okay, so that on clause is basically what you're matching criteria between the two. Okay, so for example, with our orders and users, we might do select star from orders, join users, on orders.userid equals users.id. Okay, and we'll do some examples of this. So I'm talking through this a little bit quick, but we're going to do live coding, like live kind of querying after this. So, okay, now I want to just change this around a little bit, just so it's easier to understand what we're about to get into in terms of the different types of joins. Okay, so I'm just going to change this query. I'm just going to change the names of table 1 and table 2. That's all I'm going to do. Okay, it's the exact same query, but I'm just going to change the names of table 1 and table 2. So I'm going to call table 1 the left table and table 2 the right table. Okay. So really what you have is select star from, and so whatever table you're selecting from, we call that the left table. And then whatever you're joining it to, we call the right table. Okay? That's going to become very important when we talk about the different types of joins, which we're going to talk about right now. There are 4 main types of joins that you're going to deal with. Okay? The 4 types of joins you're going to deal with are inner joins, left outer join, right outer join, and full outer joins. Okay? Now, depending what vendor you're using, PostgreSQL, MySQL, Microsoft SQL Server, SQLite, depending what you're using, there may be slightly different syntax for this. I'm basing a lot of this lecture on PostgreSQL, so you just might have to look up your syntax for your database vendor, okay? But the concepts are generally the same. Some databases call them slightly different things, but you should be able to generally Google this and find out how it works for your specific database. Okay, so what are the different types of joins here? And we're going to do examples of this. So if you don't get it right away, just hang tight. Okay, an inner join is you're only going to show results where there is a match between the left table and the right table. I want to show the results where there's an order and a user match. Okay, so if you have some order that has a user ID of like 55, and there is no user with the ID 55, that row is not going to show up. You're not going to see that order row. Okay, and it works the other way around too. For inner joins. For inner joins, if you had a user, okay, of ID 60, and there were no orders with the user ID 60, that would not show up either. You would only see the situation where those rows match, okay, and it ignores everything else, okay. So this is why inner joins sometimes get confusing, because when you're doing inner joins, sometimes you'll be like, how come that user isn't showing up, or how come that order is not showing up? Because inner joins require that you only show require that there's a match on both sides, and only then will you show the result. Okay. A left outer join, okay. A left outer join, it's going to show all the results of the left table. Okay. So regardless of the match to the right side, it's going to show all the results of the left table. Okay. And then it's going to join those up to the right table. So that means if the left table is referencing a foreign key and that doesn't exist in the right table, that record's still going to show up. But what's going to happen is all those columns from the users table are just going to be blank, or the right table, I should say, are going to be blank. So let's take our example again. If you had orders as the left table, users as the right table. If you had an order that was referencing user ID 60 and there was no user ID 60, what would happen is you'd still see the order show up, but the first name, last name, the user ID, those kind of things would just be blank. Okay? That's a left outer join. A right outer join is the exact opposite. So a right outer join would basically be all the results of the right table show up regardless, and it would join up with the left table. Okay? So that means that if you have, and lastly, you have a full outer join, which is basically going to show all the results of the right table, all the results of the left table, all joined up. And in the cases where the right table doesn't have a match, it's going to show empty fields. And in the cases where the left table doesn't have a match, it's going to show empty fields. Okay? That's what a full outer join is. All right. So those are the 4 types of joins. Let's see this in action, and it'll hopefully become a lot clearer. Okay, so we're using PostgreSQL again, and we're using pgadmin. All right, so before I got started today, last lecture we had the products and the users table, and then I just added an orders table. Okay, so let's just take a look at what those are. So if we look at the users table, you can see it here. The users table has an ID, a first name, a last name, an email, and age. If we took a look at the orders table, it's very similar to what was in the lecture or the talk. We have an ID, a subtotal, a total, and a user ID. Okay, so let's add a bunch of users to kind of get us going. Okay, so I'm going to insert into users. What were the columns that we had? So we have ID, first name, last name, email, and age. Okay, now remember the ID we're going to say is our ID is we're going to say is our primary key. So we have to make sure that's unique. I just got a question here actually that came up. FRT 550 says, what are the use cases for a right join if you can simply use a left join and swap the tables in the query? That's a very good question. Off the top of my head, I don't think there actually is a reason for why would you use a right join if you could just use a left join and swap the table names. If you're doing simple queries, that's true. There really is no difference. You may as well just do that. But it might depend a little bit on the data that you're returning back to your application. You may be more concerned with the data from the actual left table than the right table, and you may be doing other stuff with that queries. I'll be honest, off the top of my head, I can't think of any example off the top of my head, but there would be things where I'm pretty sure like the columns that you want back might only have to do with the left table, and you might want to deal with those more. So that might be a situation, but in general, I would say I can't think of a reason, or I can't think right off the top of my head why you couldn't just use a left join and swap the tables. That's a very, very good point. If I come up with an example in this, I'll definitely let you know. Okay. So let's insert a bunch of values in here. So insert into users. Okay, so what we have here is we just want to make sure the ID is different. And then I'm just going to put a bunch of generic names here. And let's just do a bunch of them. 3, 4, 5, 6. And okay, and let's give them different ages as well. Okay, so just put a bunch of guys in there, and let's just make sure they look good. Okay, so now let's insert a bunch of orders and actually take use of this foreign key here. Okay, so I'm going to insert into users. Now you can also see I already have a couple orders in here, and order 1 is referring to Casey. Sorry, order 1 is owned by Casey. Order 2 is owned by Casey. Order 3 is owned by Max Smith. Okay, so insert into users. Whoops, not users. Insert into orders. So do ID, the subtotal, the total, and then the foreign key. Okay, so remember, it has to be unique ID because we're saying that's our primary key. And we'll do a couple of values in here. Okay, and I'm going to leave that blank for now until we decide who we want to give these orders to. Okay, so 5, 6, 7. Okay. Now, to kind of demonstrate all these joins, I want to actually have some users that don't have orders, and I want to have some orders that are referring to users that don't exist. Okay. So, okay, I'm going to assign the fourth order to, say, Jill. No, Jill already has an order, actually. Let's do to Max. Okay, so Max is ID 4, so I'll put that in for the user ID. The next order I'm going to assign to, say, Sarah. The one after that I'll assign to Sarah. And then the one after that I'm going to assign to a user ID that doesn't exist, so 100. Okay, so there's no user with the ID 100, so we're just going to do that so we can demonstrate what this looks like. Okay, so let's execute those. Take a look at orders. Okay, and there we go. We got all our orders. Okay, various totals and subtotals. Well, they're all kind of buying the same stuff, it looks like, because we didn't change the totals much. Okay, now we have what we need to start looking at join queries. Okay. All right, so again, let's say we want to show order number 1 and its associated information. Okay. So what I might do is in my ORM, again, the first approach might be, okay, I want to show order number 1. So I'm going to say select all the columns from the orders table where the ID is equal to 1, and I execute that. Okay. And this would come back. So I got order number 1 with a subtotal of 100 and total 100. And the user ID is 1. Okay. And then using my ORM, I would extract that number 1 And I would do another query, and I'd say select star from users where ID is equal to 1. Okay. And I would execute that, and then I would get the first name, last name, and email. Okay. So this first query, okay, I would extract user ID equals to 1, and also store the order ID, the subtotal, and the total. Okay. And then after that, I could execute this query to store the first name, the last name, and the email, so I could show that on the order. Okay. That's how we would do it if we didn't know how to do joins. So now let's do a join. Okay. So what I'm going to do is I want to get the orders record, but with it, I also want to get the associated columns from the user table. Okay. So I'm going to do select star from. Okay. Now my left table is going to be orders, and my right table is going to be users. Okay. So when I do this, I should see the first couple columns will be the orders columns. And then after that, it'll be the users column after that. Okay. So from orders, join users. Okay. And what we're going to join it on is we're going to say that the orders user ID has to match the users table's regular ID. So we're matching the foreign key in the orders table to the primary key in the users table. So what this says is basically say, okay, do a join and select all the rows in the orders table, okay, that have a match to the users table and show all those columns side by side. Okay, so let's execute that. And there we go. Okay, so you can kind of see the split here. So the first 4 columns, 1, 2, 3, 4, these 4 columns right here are the orders table. Okay. And the columns after that are all the information that's coming from the users table. Okay. Now you can see what's kind of interesting here is that we're starting to get duplicated data because we're returning rows, right? And this is what joins do, right? Because yes, on the left table, there's no duplicates, but we're joining to a table where there's duplicate information. That makes sense because we had 2 orders that belong to Casey and 2 orders that belong to Sarah, right? So those would naturally have duplicate information there. Okay. So that's how you do a inner join. Okay. Now you notice here, we don't have order number 7, I believe. I think it's order number 7. Let me check out our orders again. Okay, if we look at orders, whoops. Okay, if we look at all the orders, there's an order number 7 here. Okay, but order number 7 references user ID 100, which doesn't have a corresponding user. Okay, and because we're doing an inner join, that's not going to return any rows back. Okay, so that is our inner join. Okay, now let's move on to the next join. Okay, so this is our inner join. So now let's say I want all the orders and all the user information, regardless if there's a user associated with it or not. So here we're going to do our left inner join. Okay. So my left table is going to be orders. So I want all the orders, regardless of if there's a user attached to it. Okay. So what I'm going to do is I'm going to do a left outer join on users and on the same criteria. Okay, we execute that. And there we go. So now we have all the orders, regardless of if they have a matching user. And you'll see, let's do a right outer join. So to select star from orders, right outer join on orders. Execute that. Okay, you see what happens here. Okay, so we have all the orders that have a matching user. Okay, But then it also returns back the users that don't have an order. Okay. And it just leaves those order fields as null in that case. Okay. And then lastly, we will do the full outer join. So do all the results that you get for inner joins, but then also list all the orders that don't have a user and all the users that don't have an order. So full outer join with users where there is that match. Okay, so that's just the one extra row there. Okay, so we have all the results of the inner join up top here. Then we have the left outer join, so which is this order without a user. And then we have the right outer join, which are these users. Let me just disable my webcam. There we go. These users without any order information. So that's a full outer join. Okay. So that is the difference between the different outer joins and how you use primary keys and foreign keys. So hopefully that makes sense now. Hopefully, that makes sense. And what's really nice about really good ORMs, we talked about active record last week, and we also talked about query builders. Sorry, I just got distracted by the question. I know there's a delay there, but good ORMs will have, or good query builders will have this functionality built in, so you can do things like that. Got a question from Shadowman. Is the full outer join the same as a union? Great question. So I believe they are. I can't remember how unions work and if they're supported in all SQL databases. Let me just bring up this here. If we talk about Venn diagrams, they are definitely the same. A union would be the same. It would be all records that lie to the left and to the right and to the middle. But it's a good question if they're exactly the same. It looks like SQL does support union. That's a great question. I don't actually know what the difference is. How is union? It might be the same thing. Oh, they do have differences. Okay, so this is something I didn't know. Unions and full outer joins do have differences. Code snip select all, union, full outer join, result. So it looks like the union is not returning the null values, but instead is just is combined. Okay. No, it looks like they are quite different, actually. Yeah, sorry. If I understand this correctly, and I could be wrong about this, but union sounds like what it's doing is actually treating two tables as a singular table. Okay, like if you had, let's say you had a table. Let's say you had a table called orders, and the only two columns in that orders table were ID and created date, and that's all that was in there. And so what a union would do is it's almost like treating those two tables as a single table. It's like stack all the results of your invoices and stack them on top of on top of the other thing. Stack them on top of the other table, and then treat them as one singular table. And you're selecting columns from that. That's why unions have to have the exact same columns on both. Okay, so whereas a join is you're combining columns together. Okay, like you're combining the data from one set of columns and joining it with columns from another table and return that as a record. Okay. Whereas union, you're actually stacking the results and you're returning values from that. So that would be the difference. So that's a really good, I didn't actually know that to right now. And if I understand that post correctly. So joins, it's all about putting tables like side by side, okay, and getting all the columns across those tables. Whereas union is like stacking the data on top of each other and getting all those values together. Okay. So for example, I wonder if I can do that here actually. So if I were to do select star from orders union users, I could only do it on the columns that match. Nope, I have my syntax wrong there. Oh, yeah. Okay. It's actually two entirely separate queries. Yeah, that's what's happening. Yeah, exactly. Okay, so think of it this way. So a join is a single query, and you are grabbing columns from one table and merging it with columns from another table to create one big set of results, right? Sorry, you're doing it to create a set of results with all these columns together. What a union does, think of it as doing two independent queries and just stacking the results on top of each other. Okay? That's what a union does. Okay? So union is like stacking the rows on top of each other, whereas joins are like putting the columns side by side with each other. Hopefully that's a good enough visualization. Great question. It's always good. It's always good when I learn stuff in these things. Okay. So hopefully that cleared that up. Okay, so one other thing I want to talk about when doing joins is some really nice, easy techniques to help you with your joins if you're debugging things and trying to figure out how to do your joins. A lot of times in Ruby on Rails, I use the query builder. And before I go to the query builder, I usually come into SQL first and just kind of do some things here. And to do that, I kind of start to write up my joins in here, kind of piece by piece until I have exactly what I want. Okay, so I'm just going to give you a couple of examples here of ways that it's easy to kind of write the data that you want. And the number one thing here is aliasing tables. Okay, what aliasing tables means you can alias columns as well. Okay, it means giving another name to a column or a table. Okay, so for example, if I did a select, star from users. Okay, we got all our users here, right? But let's say I wanted the ID, the first name, the last name, these kind of things to be named differently. Okay, I could do this. So first of all, I haven't shown you this, but you can select individual columns from a database. Okay, there we go. So we have ID, first name, last name, email, and age. So what I could do is I could name these columns differently. I could say ID is column A, first name is column B, last name is column C, email is column D, and age is column E. Okay. So there you go. I changed the name of the columns. Okay. You can also use the word as, I believe. As works for that too. But it's a shortcut just to put a space after it. Okay. So select ID as A, first name as B, and so on and so forth. So that's a way you can alias stuff. Now, that's not particularly useful here, but where it gets useful is in joins, because joins can start to get complicated. Like if we look at the inner join up here, okay, and we execute that. First of all, we have two ID columns, right? So if I'm looking at this, I'm like, well, what is this ID column? I don't know which one that is, right? Especially if we don't select all the columns here, right? So remember, when you say select star, you're saying return all the columns based on this query. But if you only wanted a couple columns, let's say I wanted the ID, only the ID. Okay, you'll see there'll be a problem here. Okay, it says, okay, you're telling me to get the ID from this join, but it's ambiguous. Do you mean the order's ID or the user's ID? Okay, well, I can be very specific in joins. So in joins, what you can do is specify which table you want that column to be from. Okay, so I could say the order's ID. Okay, so it's a dot. So table name dot field name. Okay, so if I execute that, that's only returning the order IDs. Okay. And let's say I want the order IDs, and then let's say I want the user's email. So I could just type email because this is not ambiguous. Okay, because there's only email in the users table, so that should work. There we go, email's there, okay? But I think it's good practice to put the table name in front of there because then it would be a lot easier to tell. Okay, now I'm selecting the ID from the orders and the email from the users based on the join that happens. Okay, so you can see my kind of process there. So my process generally is I start with a very simple join. Okay, I just select all the columns. Okay, orders, join users on orders.user ID, users ID. Okay, so that's everything. Now I'm only concentrating on the actual fields that I need. So then I change star to just the fields that I need. Okay, I only really care about the ID, the total, and the email of that user. Okay, there we go. It's in there. Okay, now here's where we can use aliases again. Aliases come very handy in here. Okay, so what I can say is, so these are the two tables we're joining from, and maybe it's a little bit tedious to type orders, users, orders, and over again. So I can give those tables an alias. So I'm going to say orders is table A, and users is table B. Okay. So I'm gonna select some columns from orders that I'm going to call table A, join with users B. Okay. Here I might need the as. Let me just see. Yeah. As. Oh, sorry. Okay. Because I've renamed them, now I can reference them here, I believe. So table A, table B. And same thing up here. And there we go. Okay. So because I've given them an alias of A and B, and you can call it whatever you want. Okay. Generally, you'd only do this to shorten your table names, right? Because if you make them really long, then why don't you just call it the full table name itself? Okay. But this is a way to be very explicit about the columns that you're selecting. And also another way to shorten up how you type it up. Okay. So that's a way to give aliases. And then you can further give aliases to these as well if you wanted. Okay. You can say A, B, and C if you wanted. Okay. And that's not really great because that actually gives less meaning here. One thing I would do though is things where they're ambiguous. Okay. So let's say I'm selecting, the ID from both of them. Okay. I'm going to select the ID from orders and the ID from the users. If I execute that, now I have, ambiguous columns to me, the user. They're not ambiguous to SQL because we've given them these prefixes A dot, B dot. But for us, they're ambiguous. So it'd be nice if these were actually different. So I could just call this, say, the orders ID and call this the user's ID. Okay, and that might be a bit clearer for me to read. There we go. Orders ID, total users ID, email. Okay. So just a bit of example how you give your column names and your table names some aliases. Okay. Another question for Channel Man. This might be a little bit delayed, definitely. How do we give aliases to one column and leave the rest of the columns untouched, yet query every column without having to type? Okay, but we still want all the columns, right? Okay, so I think we might be able to do that with star comma. So let's see here. Okay, so we have all the columns here, and we only want to touch, say, this column. So if I do star and then comma users ID as, call it users ID. There, we could do it that way. Unfortunately, what it does do, though, is it gives you a duplicate column. So you still have this ID column that's not renamed, but you have it renamed over here. So you would get extra columns. So you could do that, star comma that, and that would give you an alias for that column. So in that situation, either visually you just ignore this column, Or if you're using, again, your code to deal with this, you wouldn't have to, you just ignore, just don't use that column. I'm not aware of a way to say select all these columns and then only alias one of them. That I'm not aware of, but this would probably be the quickest way to do that, is star, comma, and then that. So hopefully that would address your situation, Shadow Man. And hopefully, Shadow, again, I know there's a delay. Hopefully the union versus the join was clarified for you there. So great questions, by the way, guys. I'm very happy with the participation tonight. It's definitely up for the last couple weeks. I know the last couple weeks there are definitely exams going on, so really appreciate you guys joining me live today. So that's it. So that's pretty much it for the formal lesson, talking about primary keys and foreign keys, and then join. So just to reiterate, primary keys are primary keys are unique identifier. I'm constantly getting distracted by the chat. Primary keys are columns that uniquely identify a row. Foreign keys are a reference to another table and their primary key in that other table. And then joins allow you to combine columns from multiple tables in a single query, whether that be an inner join, left join, right join, or outer join. And we learned tonight that union is a way to stack results from multiple tables. Okay, great. All right, so that's pretty much it, guys, for tonight in terms of the formal lesson. But as always, I like to stick around to do some Q&A, whether it be on tonight's topic or other topics or suggestions for other topics. Me and Dave are looking for some kind of coding, kind of pair programming coding exercise to do. So if you guys have any suggestions for something you'd like to see from two very seasoned web developers. Dave's been doing web development since, I think, like mid 2000, like 2005, somewhere around there. I've been doing web development since around 2008. And we both have really embraced it and really love it. And, I've definitely learned a ton from him. So if you have any suggestions, definitely leave them there. In terms of other questions, guys, again, if you're new to this channel, new to this video series, this is what my day-to-day life is everything on the left. So Ruby on Rails, React, HTML, CSS, JavaScript. So a lot of web development stuff. PostgreSQL. So a lot of web development, full stack. I do a bit of mobile development as well, React Native and Expo. And I use a bunch of tools like Heroku, Git, GitHub, Bitbucket, Adobe Creative Suite. And more recently, Sketch, actually. I've been using Sketch a lot more these days. And then on the right side are stuff that I have dabbled in but haven't touched in a long time. I grew up on Java in undergrad at University of Ottawa, but haven't done Java in a long time. My first web development, I shouldn't say my first web development, but when I really first started getting into web development, JSP was where I started. But I also did ASP.NET and C#.NET and actually classic ASP. And done a bit of Objective-C. And I've done a bit of Swift, and I've done very little of Node.js, although a lot of the lessons about JavaScript carry over. All the web JavaScript that I've done also kind of carries, a lot of that carries over to Node.js as well. So they both use the same language and syntax, just different libraries, different access, those kind of things. So if you guys have any questions, start funneling them in. I'll stick around for maybe 10, 20 minutes to answer some questions, or if you guys have any suggestions or like to chat about anything at all, this is kind of the open part of the talk. So again, feel like I've had a tiring week or something. It was a good week. I don't know. Hopefully everyone else is staying happy and healthy out there. I know it's definitely a lot going on in the world right now. So happy to chat on anything you guys might have questions about. I got a question from Mark here. Earlier you were talking about query optimization. I think a good idea would be to query your result, then put the result in a Redis DB. Interesting. Okay, so for those who don't know what Redis DB is, Redis is I guess they call it a memcache. Memcache is kind of, think of it as like an in-memory database. So, we talk about databases as being persistent storage a lot, and even though Redis has this ability, what you get is Redis basically is kind of like it basically is like key value pair storage, but in memory. And then occasionally you can write it to the disk if you want. So what Mark is saying for query optimization is you could query the result and then put the result in the Redis database. Now, depending how you're doing that, that is very true, Mark. That's definitely really, really good way. So like, for example, if you were going to do, say, a join between the users and the orders a lot of times, okay, let's say you do it a lot of times, then what you might do is you might do the join query once, and then when the result comes back, store that somewhere so that you always have this kind of reference, and then only use Redis at that point, right? And then if that stuff ever gets updated, you kind of come up with this update kind of algorithm or whatever. And then if you only access Redis, and you store it in a way that it's all the information together, then that would be a great way to do it. And that is what we call denormalization of data. You're basically taking data that's normalized in like a database, and then you're putting it into a form that's denormalized so that it's easy to query over time. And then as long as you keep that denormalized database up to date, then that would be great. And that is actually very true, Mark. That is definitely a very advanced way of doing things. Good on you for understanding that. If you guys have ever heard of things like Elasticsearch, that's exactly, as far as I know, I've only dealt with Elasticsearch a little bit, but as far as I know, that's how they work actually. So Elasticsearch is a way to search your database and return results really quickly. And what they do is they kind of ingest your database into a separate database, something like Redis, right? I mean, they're probably using something different, but they would take your database and they would take the information and store it in a way that's optimized for what you're doing. So let me explain that. So we have our normalized data in our database here. And so we know what our normalized data looks like, right? So we have the users and we have the orders. But what you could do is you could do that join, right? So you could say select star from orders, join users on orders.user ID equals, what am I saying here? Users.id. Okay, so now all those results come back. And what you could do is from the results that come back, you might then store something in a Redis database. Okay, and it looks something like this. So you say order, and the ID is 1, and the subtotal is 100, and the total is $113, and the user name is Casey, and the last name is Lee. Okay, because you know as a programmer that your user interface generally needs the data in this format. So what's happening here is we're storing this data in here knowing that this data is not going to change. Okay, and then if the data changes, we update this in some way. Okay, but now once we have it in this cache here, this would be stored in something like Redis. We could then query this rather than going through SQL. And that might be a lot faster way to get it because the data is all lined up for us in one single kind of result, and we don't have to do the joins or anything like that. That is denormalization of data. And that is, again, definitely a way to do that. And what that is that's optimizing things for reads. And we kind of talked about this in the Q&A sections when we talked about NoSQL databases in the past. And the idea is that SQL and normalization of data is very much optimized for writes, okay, versus reads. Like writes is like, again, an update, a delete, an insert, right? Because if you need to update data, you only have to update it in one place, right? As these SQL queries grow and these joins get really big and stuff like that, this is not necessarily optimized for reading data, right? Because how much easier would it be to read this data if the first name and the last name and the email were all just directly on the order, right? Because you could just do a select star from orders and be done with it, right? So what Mark is talking about here is kind of like a halfway in between solution where you have a normalized database, but then you then kind of migrate some of that data into a NoSQL database that's denormalized, right? And that's, again, how some services like Elasticsearch work. And that's something that I'm starting to learn as well. I talked about this last week, how I'm starting to denormalize my data, but within the SQL database itself, storing some of that data redundantly in the database, but storing it in a separate mem cache like Redis or any NoSQL database for that matter to optimize for reads is a very, very powerful thing. So if you understand that, definitely do that. Or sorry, I shouldn't say definitely do that. There are definitely cases where that's a really viable solution. And I would say that's a pretty advanced topic, actually. If you're just getting started out and you don't really understand that, doing join queries will probably get you most of the way, to be honest. So great question, Mark. That's great. That's hopefully what you intended when you were talking about that. Could we possibly do a video on a deep dive on a JavaScript framework, maybe React or Angular? Yeah, I'd love to do a deep dive on React. I can't do Angular because I've never done Angular. Yeah, I've never touched it. So I'd be able to do React, and I love React actually. The only tricky thing about doing a deep dive in React is I think we'd have to span it across multiple sessions. So we'd probably do kind of like what we're doing with SQL right now. Like for the last, there's been almost three videos on SQL now. One was ORM, but like two of them are, so the more SQL videos I do, kind of more deep dive we get into it. So yeah, I think React would be great to do. I'd love to do React because it also lends itself well to showing you guys how React Native works and Expo works, and doing some kind of complex things like that. So yeah, I would love to do React. If I don't come up with another topic by next week, maybe next week we'll do an introduction to React. Now, there's also a couple other things with React that I think we'd have to dive into. I'd like to kind of maybe do a talk about Webpack and do a talk about NPM and how node modules works, because to kind of get set up with React, you kind of have to understand node and these server-side JavaScript and how they process things like that. I shouldn't say you have to, but it's nice to understand that to get set up. But yeah, I can definitely do React. I think that would be great. There's also other ones. I know Dave has been using Vue, and Vue and React kind of sit on the same level. I think in terms of JavaScript frameworks, they only handle the Vue layer of they only handle the view layer of the front end. They don't handle a model view end controller like Angular does. But yeah, I love React. React is amazing. If you want to learn more about React, Shadow Man, I think we should let's do it. We'll put it into the calendar. If I don't come up with a topic by next Thursday, intro to React is where we're going. We'll definitely have that. And so just curious, Shadow Man, have you done any React yet? Have you touched on it at all? Because it would be nice to know how far into it you are and what would be most beneficial for you. So I'll wait for that answer. Mark, then every time you need the same data, you hit the Redis database. Since it's no SQL database, it'd be much faster. Yes, exactly, Mark. That's exactly it. Yeah. I think Mark is in like second year right now or something like that, second year university. And man, like understanding that as a way to optimize your performance, good on you. That's super advanced topic. Great stuff. Cool. Any other questions? Any other thing? Again, I really want to thank you guys for joining this. This is definitely the highest turnout we've had in a while. It's been, Dave has been very consistent, and thanks for all the support, Dave, and for kind of watching me on Thursday nights. Mark came last week, which is great. I have a couple more people here. So Shadow Man, nope. I'm just very curious on it. To be honest, I just started getting into JavaScript, but don't worry. If we actually do a dive, I'll read it home myself. Yeah, Shadow Man. No, I think it's good to know that you don't have any React experience. So that's great, because I think learning about things like Webpack and NPM and how node modules work and stuff like that, that's going to be good knowledge anyways to have. It's good to understand that stuff anyways. So we might do a little bit on Webpack and Node, just to kind of get started, because if you're going to start React from scratch, you kind of need these components. You need Node, you need Webpack to get kind of React going. So I don't think it's a bad thing to get into that. But I just didn't want to do it if you kind of understood that stuff already. So yeah, I will find a way to kind of do some introductory React, but I think we should also cover a little bit of Webpack and Node as well. Dave, I think Vue.js more so sits between React and Angular. It is much more opinionated than React, but not as much as Angular. So Dave is saying that Vue is a lot more opinionated than React, but not as much as Angular. And this actually just brings up an interesting topic about opinionated frameworks. If you guys have never heard this term, it's a great term to learn. I personally prefer opinionated frameworks. Some people hate them. But what opinionated frameworks are basically opinionated frameworks have an opinion. In other words, they promote and encourage developers to use certain conventions. Okay, so for example, PostgreSQL, SQL Database by itself don't tell you how to name your tables or how to name your columns, right? Ruby on Rails is an opinionated framework. It has an opinion on how you name your tables and how you name your columns. So it says, look, if you're going to use Ruby on Rails, you should name your tables this way. You should name your columns this way. You should do things this way. You should do things that way. That's what opinionated frameworks do. And different opinionated frameworks have different ways of implementing their opinion. Ruby on Rails, for example, it implements its opinion using convention over configuration, which basically means it says, okay, we have an opinion about how you should do stuff. And if you do things according to our opinion, then we will not require you to configure anything. You don't have to code anything. You just name things the way that we have an opinion about, and we will do the rest for you. Okay. Some opinionated frameworks, I assume, although I haven't used many, but some opinionated frameworks, I assume, opinionated frameworks will just basically say, this won't work unless you do it our way. Okay, like you have to put your files here, you have to name them this way. That's how it works. So that's what opinionated frameworks are. Opinionated frameworks are basically in situations where it's possible for one developer to have an opinion over another developer. An opinionated framework sides with one of those developers. They say you should do things this way, not this way. So yeah, that's interesting to know that Vue is a bit more opinionated than React. That is the thing about React. React is very unopinionated. It only has a couple of it has very few concepts. Like I always say that the best thing about React is that it has about 5 concepts, and those 5 concepts solve like a billion things. But then it also means that you're kind of left up to you to figure out all these higher level problems yourself, right? The reason I like opinionated frameworks is that opinionated frameworks dictate things that I don't know, like I don't have an opinion about myself, and that I don't know how to do. So Ruby on Rails like tells me where to put my files, because otherwise I wouldn't know how to structure my files, right? So that's what's really great about opinionated frameworks. What's bad about opinionated frameworks is that if your opinion differs from their opinion, then you're fighting against them, right? So, Mark, sorry, let's go back here. Shadowman, great, thank you, Casey, for these live stream. I'm always learning something new from these. Great. Happy to have you on board, Shadowman, and like your questions are really great. Like that union question was really great. So, Mark, React would be awesome. Plus the new hook API. Yes, hooks in React. This is the one thing I must admit I don't like about React, and I don't think I really understood it till I watched this video from Chris Dawes, I think is his name. I brought him up on this live stream before. He made a really good video about why React kind of sucks right now. And I kind of agree with it. I didn't really think about it till he brought it up, but React is in a kind of unstable state right now. React for the last 3 or 4 years has been going through all these different iterations to execute basically the same thing. It started with class components, then moved to functional components, and now they're moving to hooks. And they're all essentially executing the same thing, which is kind of annoying. They're not giving you a ton more. Like yes, functional components are a bit simpler than class components. And yes, hooks can give you a better way to reuse code than class components could, and functional components. Than class components could. So it's kind of like annoying because like if you're used to coding class components, you're kind of told, oh, maybe you should go to functional components. And if you're used to class components, you're told, oh, maybe now you should use hooks, all this stuff like that. So it gets a little bit complicated. I'll be honest, if I were to teach React, I would probably start with the class components, start with the old way of doing things. I think it's a little bit easier to understand because functional components kind of requires you to understand some nuances about JavaScript. And then I would kind of go into hooks and stuff like that. I only like as recent as last week was the first time I actually really started using React hooks. I don't see the huge benefit yet, but I understand the benefit. There's a lot of code reuse that you can have, which is great. But I haven't gotten to that point in my code where I'm reusing a lot of code between my components. So, but yeah, definitely happy to do React. So, Dave just mentioning, A little update on Vue and how it sits between Angular and React. Vue comes with a router. It comes with a data store. That's interesting. It comes with both a router and a data store. That's cool. And server-side rendering and really create development server out of the box. Oh, that's cool. Okay, so Vue comes with a lot of components that React doesn't. React has a library called Create React App, which handles a lot of this stuff for you, which is great, but it isn't part of React itself. React definitely doesn't have a router built in, so that's really cool. And it definitely doesn't have a data store. So that is something that I've managed to escape for years not doing. There's something in React called like Flux. It's kind of it's a solution pattern to kind of communication between components. Definitely haven't had to deal with that yet. So it's interesting that Vue comes with all this stuff. So very, very cool. Okay, so yeah, lots of great chat, guys. Looks like there is definitely a demand for React here, so maybe React's the way to go. Again, if I definitely want to do something with Dave too, like again, some kind of pair programming, or even just talking about things, bring him in for an interview or whatever. Yeah, definitely lots to learn from him for sure. Yeah, but again, if you guys have any more questions, keep them coming. But really want to thank all of you guys, Dave, Mark, Shadowman, and FRT550. Thanks for joining, guys. It's been really, really great. I love it when there is actually this kind of discussion. It really, really, really helps for sure. And hopefully you guys learned a little bit about primary keys, foreign keys, normalization, denormalization, these kind of things. I didn't really understand normalization versus denormalization until I got into NoSQL databases. So definitely very interesting there. All right. So we're coming to 9:30 here. But if you guys have any last minute questions, throw them up. But otherwise, don't forget to spread the word now that exams are over. Hopefully, we'll get a couple more students on board here. Definitely always interested in that. Definitely always interested in it. So definitely spread the word. I want to thank everybody who's been liking my LinkedIn stuff and my tweets about this. And again, for keeping this going. I think this is week number 6. So really happy with the way things are going. But yeah, don't forget to subscribe, hit the bell icon, tell your friends and family, anybody who wants to learn software really. Follow me on Twitter and retweet my tweets or whatever. Anyway, you guys can help me spread the word is always very much appreciated. And now school's over. Congrats to the students on your exams, and hopefully, most of you guys were able, to find your co-op jobs. I know a lot of companies had to cut back, obviously, on co-op with what's happening with COVID. But if you weren't able, if you're in an unfortunate position there. My advice is if you really can't find a job, just try as much as possible to learn as much as you can by yourself. Software is one of those fortunate fields where you can really learn a ton by yourself. So pick a project, pick a language, pick a framework, just find any way you can to keep that education up. It can really help. There's nothing that will make you learn faster than building something for somebody else. So I always say, like, find somebody else to build an app for, or a website or a web app or whatever it may be. So cool. Okay, awesome. All right. Thanks, everybody. I think I'm going to shut it down there. Really appreciate it. We will see you guys next Thursday with potentially React, potentially a pair programming session with Dave. Who knows what it'll be. Keep an eye on my channel. Keep an eye on my LinkedIn feed, Twitter, whatever it may be. And we'll catch you guys in the next one. Thanks so much.